Hey guys, it's Mr. Zimmerman, and today we're going to talk about the compound interest formula. All right, so essentially, this is a minor adjustment of the growth formula, and you'll see that there's this new thing, k. K is in the exponent, and it's also dividing by the rate. K basically means the number of compound periods, and it just gives us a little more flexibility so that we're not just limited to solve problems based on the year. So let's go ahead and jump in. So basically, we're going to have to write a formula to model the amount of money in a savings account. So when we're modeling a savings account, you have to remember that if we get an answer that is not bigger than how much money we put in, something went awry. So P, the principal, is going to be the starting amount, which is $500. And now I'm going to multiply it by 1 plus the decimal version of 0.06. Now, it's going to be divided by 1 because it's compounded once a year. So nothing fancy. We're going to multiply the exponent by 1. Now, I'm going to clean this up just because I like things that look slick and clean. I'm going to combine my like terms, and voila, I get something nice and easy to input. Because I spent the time to clean it up right here, my further steps are going to be a little easier. Now, I got to figure out how much money is in my account after 1 year. This is standard 4.2. Basically, can you use the formulas that you made up? So I'm going to substitute in 1 for my exponent, and I'm going to get an amount of money that should be just over 500. Nothing too much. You don't actually earn that much. It's probably way better to actually invest your money, but that's a topic for another day. Now, I'm going to do this again, but I have to plug in 5. So it's going to be $500 times 1.06, and it's just going to sit here for 5 years. Go ahead, use a calculator to figure out how much money would be generated. Now, all right, this is where it's different. We have to calculate 2 things. How much it is monthly, and we have to figure out at the end of the year how much money it is. Basically, we're trying to get some perspective. So we're going to go ahead and first write our formula, and it's going to go ahead and be $500 times 1 plus 0.06. Now, it is going to be divided by 12 because there are 12 months in a year. Now, I am going to clean this up because I'm a boss and I like things to be nice and easy. A of t is going to be equal to 500 times 1.05 to the 12t. Now, I'm going to go ahead and plug in 1 for t, and I'm going to get 500 times 1.05 to the 12th power, and you should get an amount of money. For further discourse, look and compare the amount of money generated in number 1 and number 4. Now 5 is going to be very similar because the linguist, it's the same. We want 1 year, but this time we need to know compounded weekly. How many weeks are in a year, you might ask? Well, the answer is 52, always. 500 times 1 plus 0.06. We're going to go ahead and divide it by 52. And I'm going to get 52t. If you ever get a decimal for the quotient for this part, just leave it. Let the calculator do the work. Speaking of letting the calculator do the work, I'm going to plug in 1. And I'm going to get 500 times 1 plus 0.06 divided by 52 to the 52 times 1. And you should get an amount of money. Like I said before, compare this to how much money you made in 4 and 1. And you're going to realize that compounding monthly and compounding weekly don't happen in the real world because they give far too much money for just having something sit around. So just make sure you're familiar with this formula, how to use it, and how to simplify it. That's it for now. Ciao.